This is the answer to Chapter 10, problem number 75 from the Smith Organic Chemistry textbook. And this problem asks us to draw a stepwise mechanism for the reaction that the problem shows us. And so we have cyclopentene with an alkyl chain substituent with an alcohol on it, and we're treating that with sulfuric acid, and we're ending up with a two-ring system, a bicyclic system. And so at first, when I first looked at this, I was tempted to think, okay, well, the oxygen is just going to act as a nucleophile. But when you look again, there's no oxygen in the product, and there's certainly no oxygen in the new ring that's formed. And so the oxygen isn't going to act as a nucleophile. And so the nucleophile is going to have to be the electrons in the double bond in our starting material. And so we're going to form our carbocation by elimination of the alcohol. So our first step is going to be this. So there's our sulfuric acid. One of the lone pairs on this oxygen will grab that proton and become protonated. Okay, and so the oxygen only has one lone pair now. It has a positive charge on it, and so this is good conditions for this to leave as water. And so that's what will happen. The carbon-oxygen bond will break. And so now we have a newly formed carbocation here at this carbon. And so this is a secondary carbocation, but there's a tertiary carbon adjacent to this secondary carbocation that we have. And so we can draw this as a 1,2 hydride shift. So like this, which is the technically correct way to draw a carbocation rearrangement. And so now we have our carbocation on this tertiary carbon. It's more stable. And what's going to happen now is now those electrons in the double bond, like I said in the beginning, can act as a nucleophile and attack this carbocation. So I'm actually going to move everything up just a little bit. Just so that I'm not crowded here, because I am going to come down. Okay, and so after that attack, now we have our two fused rings. So we have the 5-membered ring that we started with, and we have our new 6-membered ring that we just formed. And we're going to have, so now I'll move this down a little bit. All right, so we have our two rings. We're going to have two methyl groups here. Okay, and we're going to have our carbocation located here now. And we should, to make this a little easier, draw in this proton here. And the final step is going to be to reform that double bond. And so we can use the conjugate base of the sulfuric acid. So 3 lone pairs and a negative charge. And that's going to come and grab this proton. These electrons will go here. And so now we've reformed our double bond. And we have our final product. That looks like this. Two methyl groups and the double bond. Okay, so there we go. That's the stepwise mechanism for this reaction. So again, it's protonating the alcohol leaving as a water, the carbocation that we formed there rearranging to the more stable tertiary carbocation, and then the double bond doing a nucleophilic attack on that carbocation to give us our second ring, and then just a deprotonation to reform the double bond. And that's the answer to chapter 10, problem number 75.